So this video assumes that you've already identities, like the Pythagorean ones, the double angle and half angle ones, and that, of course, that you know how to factor algebra 1 level trinomials. So first we're going to start off with solving a simple trigonometric equations that does not require any identities or factoring. Two sine x minus 1 equals theta. Equals 0. And we'll first solve this by adding 1 to both sides, and follow that up with dividing by 2 on both sides, and follow that up by taking the inverse sine of both sides, which is going to result in 2 solutions. So if the sine of x is 1/2, then x could be pi over 6 plus 2 pi k, because we can go around the circle another time and land on pi over 6 again. Or 5 pi over 6 over in quadrant 2, because that has the same sine value as pi over 6. And there we have the 2 families of solutions. Okay, we're going to follow that up with another one where you don't need a trig identity, just algebra. And I want to mention that when you see these trig expressions in algebraic equations, you want to treat the entire trig expression, the cosine x, like a variable. So if this is distracting you, just imagine it just says 4x equals 1. So I'm going to divide both sides by 4. And then, like I said, treat this like a variable. So this looks no different. The form is no different than x squared. So if x squared equaled 1/4, I would take the square root of both sides, so that's what I'm going to do here. Don't forget the plus or minus, because you're taking square root of both sides. Plus or minus 1/2. So I'm going to have a family of solutions where the cosine of x is 1/2, and another one where the cosine of x is negative 1/2. So I'll split that up into 2 branches. Cosine of x is 1/2. Cosine of x is negative 1/2. Okay, if the cosine of x is 1/2, then I have pi over 3 plus 2 pi k, as well as 5 pi over 3 plus 2 pi k. And then if the cosine of x is negative 1/2, I have 2 other groups, 2 pi over 3 plus 2 pi k, and 4 pi over 3 plus 2 pi k. Okay, so don't forget that plus or minus, because if you forgot it, you would have lost 50% of your solution set. Okay, moving on. We will need some factoring for this one. Remember, treat this like x squared, treat this like x, so I'm going to take the GCF out, which is tan x. And if tan x is 0, then x would be pi k, And if tan x is -1, then x would be, see, it's negative, so that would happen in the second and fourth quadrants at 3 pi over 4. I don't have to write 7 pi over 4 because if I just add pi k to 3 pi over 4, that's going to include 7 pi over 4 as well as all the other ones in the fourth quadrant. Okay, on to another factoring one. Two cosine squared minus 5 cosine x plus 2 equals 0. Okay, this is a trinomial. The first term has cosine squared in it, the second one cosine, and the third one is a constant. So this looks like one of those regular trinomials you would have seen in Algebra 1. So we're going to factor it into two binomials. Since 2 is prime, we know one of them's got to have 2 cosine x and the other one will have cosine x. This is also prime, so I know it's got to be 2 and 1, or 1 and 2. And 2 here and 1 here is the only one that works. Both minus. So from here, cosine of x is 1/2, and from here, cosine of x is 2. I want to turn your attention to this one first because we can throw this one out since cosine of x can never be 2. Recall when we graphed sinusoids, cosine curve looks like this, right? The max is 1, so you can never have a cosine value bigger than 1. That's good news because it cuts down on work. I can just throw that one out and just worry about this guy. So cosine of x is 1/2 at pi over 3 and 5 pi over 3. Okay, now we're going to go to number 5 here. One minus cosine x equals negative sine x. Okay, this one's kind of interesting because it doesn't look like we can use any factoring. And it also looks like I can't use any identities. I don't see a cosine squared or a sine squared. I can't use Pythagorean identity. I don't have any double angles here. So kind of a last resort move here is to square both sides. So this is what I mean. Square the left and square the right. When I expand this, I get that. And on the right, I can change sine squared using Pythagorean identity to 1 minus cosine squared. And I do that so that everything that has a trig expression in it is in terms of cosine. And now, if I add cosine squared to both sides and cancel the 1's, I'll have 2 cosine squared on the left minus 2 cosine x equals 0. I have a GCF of 2 cosine x, leaving cosine x minus 1. And from here, cosine x is 0. So x is pi over 2 plus pi k. Over here, cosine of x is 1, and that happens at pi k. Just double checking here, make sure I did that right. Okay, that looks good. I'm going to show you one more here because I want to show you one where I'm using an identity. Sine x equals sine 2x. Now, yes, everything's in terms of sine, that's good. However, this is a double angle and that's a single angle. Can't really work with that. So I need to use an identity here to change the right side into 2 sine x cosine x. Now you might think, oh, this is bad because now I got sines and cosines mixed in. But if I subtract sine x from both sides, bring it over here, and then take out a GCF of sine x, you see it's factorable, and I will get my two solutions. From here, sine x is 0, making x pi k, and here cosine is 1/2, making x our old friend pi over 3, and 5 pi over 3. Okay, so this one can trip up some people because you may not, some people may think, I don't want to use the identity because I don't want to mix cosine in, but it really depends on the situation. Mixing the sines and cosines here doesn't prevent you from solving it. Okay, so there's some trig equations for you to think about. Sometimes you need factoring, sometimes you don't. Sometimes you need identities, and sometimes you don't. Just keep practicing, and you'll get used to knowing when you need them and when you don't. Thank you for watching K109 Math, and we'll see you later.